this is how to complete a truth table. In this episode, we're going to learn how to complete a truth table by calculating the truth values for the component compound statements and calculating the truth values for the target statement itself. So let's say you have a statement like this one, which is if P and Q, then Q and R, and you need to make a truth table. How do you do it? Well, in how to set up a truth table, parts 1 and 2, we got to this point in which we created columns for each of the statement letters. We calculated the number of rows that the table will have, and we entered all of the possible combinations of truth values for the statement letters. In addition, we created columns for each of the compound component parts of the target statement and a column for the target statement itself. And now we're going to learn how to complete the columns for all of the compound statements on this table. In other words, we're going to complete the last 3 columns. So to complete the table, we're going to need to remember the definitions of the truth functions that appear in the target statement. So remember that we have 5 truth functions, and they are tilde, which represents negation, the dot, which represents conjunction, wedge, which represents disjunction, the horseshoe for conditional, and the triple bar for biconditional. Okay, so when we complete the table, we start with the simplest compound, or the one on the leftmost part of the table, and so in this case that's P and Q. So we need to consult the definition for conjunction, since this is a conjunction. And so I've got that definition here, the table version of it. And just as a quick reminder, the table here, the table definition here uses the Greek letters phi and psi. So phi is the red one here, and psi is the green one. So just to make that clear. Okay, so now when we look at the column for P and Q, and we're going to complete it, it's helpful as you start out with this to sort of identify which of the 2 parts of P and Q, that is, which of the 2 conjuncts represents phi and which represents psi. In this case, it's pretty easy. P is phi and Q is psi. So that's going to be helpful as we use the table to complete the column. Now, since this is a conjunction of P and Q, we're going to be looking at the P and Q columns that I have highlighted in red here. Okay, so now look again at the definition table. What it tells us briefly, to put it as brief as possible, the table tells us that a conjunction is true just in case both conjuncts are true, and it's false in every other case. So that's important as we as we complete this column. So now, in the first row of the table, P is true and Q is true. And if we look over now at the table definition, it tells us that when the 2 conjuncts are true, the conjunction is true. So when P and Q are true, P dot Q will be true. So we put a T in that row. Now we move down to the next row, and it's the same. That is, it's the same combination. P is true, Q is true, so P dot Q will be true again, as is indicated by the first row of the table definition. Now, moving to the third row, we have P is true and Q is false. That corresponds to the second row of the table definition, where phi is true and psi is false. And in that row, phi dot psi is false. So when P is true and Q is false, P dot Q will be false. And of course, the next row, the fourth row, is exactly the same. P is true, Q is false, so P dot Q will be false. Now moving to the fifth row, P is false and Q is true. And going over to the definition table, we have when phi is false and psi is true, phi dot psi is false. So we put an F under p.q in the fifth row. Sixth row is exactly the same as the fifth. P is true, p is false, q is true, and so p.q is false. The seventh row, p is false, q is false. That corresponds to the fourth row of the table definition, where phi is false and psi is false, and in that case, phi.psi is false. So, in the seventh row, we put a false under p.q, and the same thing goes for the eighth row. P is false and q is false, and so p.q is also false. Okay, so I went through that fairly laboriously, but I do want to point out one thing, just as a sort of a summary of what we've done. If you look at the table, what we see is p.q is only true when both p and q are true. And that, of course, corresponds to the table definition. It tells us that phi.psi is true only when phi and psi are true. The reason for that is that a conjunction is only true when both conjuncts are true. Every other row of the column for p.q is false because there's no other row where both conjuncts are true. Alright, so now we're going to move over to the next column, which is q.r. This is also a conjunction, but we have different conjuncts. Rather than p and q as conjuncts, we have q and r. But the process will be the same. We'll go through each of the rows and see what the table definition tells us the truth value should be for q.r given the inputs of the two conjuncts. So for example, in the first row where q and r are both true, q.r is going to be true. In the second row where q is true and r is false, q.r is going to be false. So again, I'm not going to go through this as laboriously as I did with p.q because I hope you get the idea by now. But this is what the column will look like once we've completed it. And please feel free to pause this, by the way, and check each of these rows if you need to. I think it's a good idea to see why we get the particular result we do in each of these rows for q.r. Okay, and once again notice, of course, that q.r is true only when both conjuncts are true. That is, only when q and r are both true. And so that would be the first row and the fifth row. In every other row, q.r is false because in every other row, it's not the case that both conjuncts are true. Alright, so let's move to the last column here, which is the target statement itself. Now, the target statement is a conditional. And so we need to consult the definition for conditional, which I have here. Again, what the table definition tells us is that a conditional statement is false only when the antecedent is true and the consequent is false. And that's the second row of this definition table. When phi is true and psi is false, then phi horseshoe psi is false. But in every other row, that is every other possible combination of truth values, phi horseshoe psi is true. So now looking at our column on our table for the target statement, in that statement, the antecedent is p.q, so that corresponds to phi from the table, the definition table. q.r corresponds to psi for the definition table. Okay. So that means we need to look at these two columns. The p.q column for the antecedent and the q.r column for the consequent. So take the first row. We have a true antecedent because p.q is true and a true consequent because q.r is true. That corresponds to the first row of the table, the definition table. And the table tells us that in such a case, with a true antecedent and a true consequent, a conditional is true. So we put a T in that row. In the next row, the antecedent p.q is true, but the consequent q.r is false. That corresponds to the second row of the definition table. And that row tells us that when you have a true antecedent and a false consequent, that the conditional is false. So we put an F in that row under our target statement. The next row, we have a false antecedent and a false consequent. That corresponds to the fourth row of the definition table, and it tells us that the conditional is true in that case, and so we put a T in that row. The next row, row 4, is exactly the same, so we put a T there. The next row, row 5, we have a false antecedent, P.Q is false, and a true consequent, Q.R is true. That corresponds to the third row of the definition table, and it tells us that in such an instance the conditional is true, so we put a T there. Now we're back to what we had earlier in the third and fourth row, where we had a false antecedent and a false consequent. That was corresponded to the fourth row of the definition table, which means that the conditional is true in that case. We put a T. Same is true of the seventh row and the eighth row. Okay, so notice that the only row in which our target statement, this conditional statement, is false is the second row, because that's the only place where the antecedent is true and the consequent is false. And as I pointed out earlier, the definition table indicates that. That is, it indicates that a conditional statement is false only when the antecedent is true and the consequent is false. It's true in every other case. Okay, so this is the completed table. So now we're going to review this and try it with a more complex statement, which I have here. This is, it's kind of difficult to read, but this statement says, if P then tilde Q, then either P or Q and R. So let's set up the truth table, and as an exercise you can pause this and set up the table yourself and check it against what I have for you. But here is the completed table, and once again you notice we have columns for each of the statement letters, and for each of the compound component parts we have 8 rows, since we have 3 statement letters. 2 to the 3 is 8. And we have all of the possible combinations of truth values put in the way in which you learned in the previous 2 episodes. Okay, so now we're going to complete the compound statement columns, starting with the simplest, which is tilde Q. Tilde Q is a negation, and I have here the definition table for negation. In this case, phi is, or Q represents phi, and so we need to be looking at the Q column in order to calculate the value for tilde Q. So look closely at the table. What it tells us is that when you have a negation is false when the statement negated is true. That is, tilde phi is false when phi is true. Tilde phi is true when phi is false. So tilde Q will be false when Q is true, and tilde Q will be true when Q is false. And I have this filled out here for us. So you'll look and you'll see that when Q is true, tilde Q is false, and when Q is false, tilde Q is true, just as is indicated on the definition table. Now we move over to Q.R. This is a conjunction. We did this exact statement in the previous case, and so this should be relatively easy to figure out by this point. And here it is. Once again, remember that the definition table tells us that a conjunction is true only when both conjuncts are true, and it's false in every other case. Okay, so now moving over to the next column, P horseshoe tilde Q. This is a conditional, so I have the definition for conditional here. Once again, remember, conditional is false only when the antecedent is true and the consequent is false. So what's important is to identify the antecedent and the consequent. So the antecedent is P and the consequent is tilde Q. So P horseshoe tilde Q will be false only when P is true and tilde Q is false. And this is the completed column, and you'll notice that P horseshoe tilde Q is only false when P is true and tilde Q is false. And in every other case, the conditional is true. Now we have a disjunction, P wedge Q dot R. We haven't done disjunction yet in this episode, but I have the table, the definition table here. And again, the quick summary is that that a disjunction is false only when both disjuncts are false. So phi wedge psi is false only when both phi and psi are false. So in our statement here, P is phi and Q dot R is psi, so we'll be looking at those two columns to calculate the column for P wedge Q dot R. Okay, so I've completed it here for us. I'll go through this a little bit slower than with the previous two. In the first row, P is true and Q dot R is true. The definition tells us that when both disjuncts are true, the disjunction is true. That's the first row. In the second row, P is true, Q dot R is false. That corresponds to the second row of the definition table, and it indicates that in that instance, the disjunction is true, so we put a T in that row. The third row is exactly the same, so it gets a T. Fourth row is the same again. P is true, Q dot R is false, so again we put a T. In the fifth row, P is false, Q dot R is true. That corresponds to the third row of the definition table, which also indicates a T, so we put a T in the fifth row of our table. Now, in the last three rows, you'll notice that both of the disjuncts, both P and Q dot R, are false. That corresponds to the fourth row of the definition table, and it's that row where we have an F. That's the only case where we have a false, and so we put a false in each of the three last rows of our table. So you see that highlighted here. The disjunction is false only when both disjuncts are false, and it's true in every other case. Okay, we are at the last column now, which is this complicated conditional statement, P horseshoe tilde Q horseshoe P wedge Q dot R. And again, with conditionals, it's important to identify the antecedent and the consequent. So the antecedent of this conditional is P horseshoe tilde Q. That, of course, corresponds to phi on the definition table. The consequent is P wedge Q dot R. That corresponds to psi on the definition table. And remember, once again, we've done several of these now, that a conditional statement is false only when the antecedent is true and the consequent is false. Okay. So in the first row, we have a false antecedent and a true consequent. That corresponds to the third row of the definition table. And in that row, the conditional is true, so we put a T. The second row is exactly the same. False antecedent, true consequent leads to a true conditional statement. Third row, we have a true antecedent and a true consequent. That corresponds to the first row of the table definition, and that tells us that the conditional is true in that row, so we put a T in row 3. Row 4 is exactly the same. True antecedent, true consequent leads to a true conditional. Fifth row is the same again. True antecedent, true consequent, so we put a T. In the sixth row, we have a true antecedent and a false consequent, and that corresponds to the second row of the table definition, of the definition table, and that indicates that in that row, the conditional is false, so we put an F. The seventh row is the same. True antecedent, false consequent leads to a false conditional, and the same is true of the eighth row. Okay, and so we see that the conditional statement is false only when the antecedent is true and the consequent is false, and it is true in every other instance. So there we have our completed table. We have learned how to complete a truth table.